Hello viewers, tutorial 2 question 1, and we have a bit of work to do with the formula 1 over f equals 1 over di plus 1 over do. So our formula that we're going to work with is that one there. So it's a formula for image distance of a lens. F is the focal length, di is the image distance, and do is the object distance. All three are going to be measured in meters. First task is to find the focal length, is to find f when di is 6 and do is 3. So we have 1 over f equals 1 over di, which is 6, plus 1 over do. Well, do is 3. We can't add those fractions directly yet because we have different denominators. One's got a 6, the other's got a 3. We need to get a common denominator. But if we multiply this 1 over 3, top and bottom, by 2, we get 1 over f equals 1 over 6 plus 2 over 6. Now they've got both of them a 6 on the bottom, which means that we can add them. So therefore, 1 over f equals 1 over 6 plus 2 upon 6 gives you 3 upon 6, which is a half. So now that we've got one fraction on each side of the equation, we can flip. So we've got f over 1, so we're flipping both sides. Don't really need to worry about that middle bit for now. That was just the unsimplified version, but what we've got at the moment is the equation 1 over f equals 1 over 2. So we're flipping both sides of that, and we get f over 1 equals 2 over 1. So therefore we get f equals 2. Focal length is 2 meters when the image distance is 6 meters and the object distance is 3 meters. A far more pressing and urgent concern is the rearrangement of the equation. How would we make di the subject? Well, we have 3 equations there, so we can't necessarily flip them at this point, which is going to mean that we need to be a little bit more witty about what we do here. If you think back to tutorial 1 question 5, I used the strategy of multiplying everything through by the multiplication of what was on the denominator. Here we'll use that same strategy again, which is going to be multiply through by everything on all 3 denominators. So times everything through by f, di, do. So we've got 1 over f equals 1 over di plus 1 over do. Haven't done anything yet, but what we will do is f times di times do, multiply everything by that. F times di times do, this will be f times di times do, and this will be f times di times do. Okay, so here we've got the f's cancelling, there di's cancel, there do cancels. So what have we got? We've got di do equals f times do plus f times di. So that cleared everything on the denominator, that got rid of it being a fraction. What we're looking to do is to solve for di. That means we want everything with a di in it on one side, everything else to the other side. That means the f times di is on the wrong side of the equation and needs to be moved. Okay, so if we move the di, the f times di, we get di do minus f times di equals f times do. So on that left hand side we've got a common factor of di, so we can take that out as a common factor. So we've got di times do minus f equals f do. So that left hand side is di times something. We can divide by that something. So let's do that. Di equals f times do divided by do minus f. and that is your equation with di as the subject. So let's confirm that just by doing a test, by doing a check. So from question A we had the combination di was 6, do was 3, and f turned out to be 2. Hopefully that combination of the three letters still holds. So that right hand side is f times do, which was 2 times 3, which is 6. The right hand side is 3 minus 2, which is 1. 6 divided by 1 gets you back to di equals 6, as we were hoping. Okay, thanks for watching. Over and out.